Hello, everyone. As Todd mentioned, my name is Jigyasa Grover, and I currently work as a machine learning engineer at Twitter, specifically in the ads prediction team. And today we'll be talking about how we can sculpt the right kind of data for our machine learning models. Um, the last couple of years have seen an immense growth of machine learning in multiple domains, and they influence from your shopping list to the car you choose to self-driving cars around the town. Regardless, basically, machine learning is most used and most abused subdomain of artificial intelligence presently. And regardless of a fascination or loath for it, it is influencing our decision-making power and dominating our lives heavily. To describe, enabling computers to learn on their own is what encompasses machine learning, the power of spotting patterns on their own without the requirement of programming is the biggest edge these decision-making programs have over the others. Researchers keep traversing these unexplored territories of machine learning, whereas according to experts in businesses, they've just seen the tip of the algorithmic iceberg, especially in terms of product and business. So according to Finances Online, 28.5 US billion dollars were allocated to machine learning just in Q1 2019 worldwide. And it is expected to grow up to 40 billion US dollars by 2025, where we just started from 1.3 US billion dollars in 2016. So there's a lot of investment in terms of money as well in the growth of machine learning. And we all know that the number of startups which focus on AI and machine learning, there's been like a 50% growth, and currently they are like increasing at the rate of 14x. And 97% of mobile users use AI powered voice assistants, with 40% of search powered by voice. Enterprise domains like security, analytics, sales, and marketing are also reaching new heights with machine learning adoption. With all of this, there are dominant, you can say machine learning is the future, right? But is it magic? Certainly not, because this is something that we have worked on. This is something we know the in and out of. So it's definitely not magic. Dominant leaps are definitely leaving scientists, investors, policymakers, business leaders, and the audience bedazzled, hinting that human-like intelligence is just around the corner. Nonetheless, progress in machine learning has been very impressive, but there's also a lot of pending explanation and examination that keeps on going. For the state of the art learning algorithm, like to put it simply, there are three key dimensions that we need to focus on: well calibrated data, sophisticated algorithms, and efficient computation. So these are the three key dimensions that we usually focus on, and that the algorithm should also, like whole machine learning domain should focus on for the magic to happen. Uh, so coming to sophisticated algorithms, the strong build of a learning algorithm comes from the iterative process of validating hypotheses through experimentation. Whereas the efficient computation comes from optimizing the learning algorithm for using distributed computing and lots of machinery that goes behind it to run at large scale. However, when you lay the foundation, the perfect quality and the perfect quantity of the data is the secret sauce for creating a successful machine learning model. Not to say like modern approaches are definitely data hungry, since we have progressed so much from the rule-based approach to a more data-driven approach. It goes without saying that machine learning algorithms are trained to capture the implicit information from the data provided. Without going into many details, just assume that deep learning algorithms, they have many parameters that we need to tune. And for that, they need a lot of data in order to come up with a more generalizable model. So in that sense, having a lot of data is a key to coming up with good training sets for these approaches for the algorithms to learn better and generalize. However, if a lot of data is important, it's also important to feed the right format of data. The type of data that actually gets into the algorithm has a profound effect on how the algorithm functions. Worthy data collection forms the foundation of the pyramid. So Monica Rogati, who is a renowned data scientist and an AI advisor, she basically drew parallel to what we know as the Maslow's hierarchy of human needs. So she drew parallel to that, an AI hierarchy of needs, and looks something like this. So at the base, we have instrumentation, logging, sensors, external data, and user-generated content, which is basically the things which we would need to generate data. And if you can see, she basically puts forward that data literacy, data collection, and data flow form the basic needs, which must be satisfied in order to achieve self-actualization, in order to achieve nirvana, which in our case would be the attainment of AI. So this is how the hierarchy of need goes. So coming back to it, how about the right format of data matters. We can also, it's also important to know that though perfect quantity of data matters, it's also perfect quality. Hence, whatever Peter Norvig says, that more data beats clever algorithms, but better data beats more data. So machine learning models are as good or as bad as the data you provide or as the data you have. So depending on the different use cases of machine learning we have, let's talk about academia, right? So core machine, like where do they get the data from and how it actually works. So core machine learning and data science research groups, be it in academic institutions or research groups, they are oriented more towards novelty, right? Towards advancing the field. And many times they weigh the novelty, the uniqueness of the problem more than the money-making logic or scaling it, right? So in this attempt to find new problems or to work on new problems, they have to find collaborators and from pertinent domains, seek funding for their research projects. These are not the only obstacles they face. They also have to look for relevant data for their particular use case in the absence of in-house data, contrary to the corporate giants who usually have access to these, right? And if you think about the industry, established organizations, they seldom have obstacles in obtaining the computation power. They have lots of CPUs, GPUs, machines. They have folks they've hired with expertise in corresponding domains they need to work on. And they even have access to data, as you talked about, like sensors data, users data, and so on. So however, the challenge comes up in scaling up their solution to massive user base. Any organization would have a lot of unstructured data available on their hands, be it raw logs. So developing an efficient data pre-processing pipeline still remains a task. And for creating such resilient pipelines, apart from relevant technical knowledge, we also require the skills to identify and curate meaningful and unbiased data sets from a vast sea of unstructured data. So that brings us to why we want to collect data, right? And how we want to collect data. So there are like different approaches of building a good quality data set. But before we talk about the different approaches, let me introduce you to three different data sets, which are also available on Kaggle, built by my co-author, Risha Mishra, just as we began writing the book. So the first data set let's talk about is the clothing fit data set. So to improve customers' online shopping experiences and to reduce return rates of the products, it is vital to have like a very nifty clothing size recommendation framework in place. So we used ModCloth, an online retailer of indie and vintage inspired women's clothing, to create data set for this use case. The data set basically contains fit feedback from customers or their purchased clothing items and other informations like ratings, reviews, category information, customer measurements, and so on. So this dataset basically helps identify critical features that determine the fit of a particular clothing based for a specific customer and their measurements. So this is one dataset. The other dataset that was created was for sarcasm detection, or just like sarcastic dataset. So past studies have shown that sarcasm detection tasks mostly have used data from Twitter, as we all know, which is a microblogging and a social networking website. The data collected from it usually is based on hashtag supervision, like Twitter uses a lot of hashtag. However, such data sets are noisy, especially in terms of label assignments and the kind of language used. To overcome these limitations, we've used the Onion and HuffPost to create a custom data set for our use case. So for those of you who don't know, the Onion is an American satirical digital media company that publishes sarcastic articles on international, national, and local news, corresponding to HuffPost, which reports the real news. So it could be like HuffPost has a real, like non-sarcastic headlines, and the Onion would have like corresponding to that, like sarcastic headlines. So this is another data set that we created. And the third data set that is in our discussion today is the news category data set. So this was again created from HuffPost, an American news aggregator and a blog. It contains about 200,000 news headlines from 2012 to 2018, having different details like news category, headlines, a short description of the news stories, publication date, author, and so on. So now that I've given you an overview of the three different data sets, let's see about how they could fit in the different approaches that we'll further talk about. So depending on how, or basically depending on why we want to collect the data, there are different ways to approach the data curation step. So let's say we have a specific problem in mind we want to address with the help of the data we will collect in future. So in that case, we have a North Star that we have to follow. We will have a guided search approach. Whereas if we are just like curious and want some interesting data points to maybe contribute to the existing data set repository that we have, unguided search should be enough to fuel that wanderlust. So basically, both these situations have their own challenges, and depending on why we want to collect data sets, we can learn how to overcome these challenges. So coming to guided search, the first approach to collecting data sets. So when we have a specific problem in mind to build a data set, we go with the guided search approach. And what are the three like main challenges that this or the main requirements? So the first would be a problem definition. You need to know why are you collecting, what are you basically the problem, what are you trying to address? And the second would be essential data signal determination. So in a layperson's term, we can say a data signal is a piece of information transmitted by a particular data point. So in the clothing fit data set, let's say our problem was size recommendation problem. So that would be like a formal problem. And there we want to recommend clothing size to customers. Based on that formal definition, we can identify the following essential data signals, which would be user ID, product ID, the size purchased by the customer, and the fit feedback, like what was the feedback on the fit of that particular item. So the ID features, they form like a vital function of tying the required information. So we know which customer bought which product, so we need to tie that up. And undoubtedly, we can also collect other data signals for a transaction, like what category was the product of, what was the age of the customer or the user, but they're not of like absolute necessity. So you can say that the skill of identifying essential data signals, like which are like of absolute necessity, they come from problem understanding, like how well can you understand the problem you have in your mind, and of course the domain knowledge. So these are the two things that you need to keep in mind when you have like a specific problem in mind and you're collecting data sets for it. There could be, let's assume that when we were building that data set, we were Googling for stuff, right? We put our web surfing expertise to use and we found Zappos, a good website to collect that data set. So for those of you who don't know, Zappos is again an online shoe and clothing retailer. So for building the clothing fit data set, we went there and we found that it provided user ID, it provided product ID, it provided the fit feedback, and then many other data signals. However, it just missed what size the customer purchased. So that signal was not present on the website. But when you think about the problem, it is very necessary for you to tie the fit feedback and the size the customer purchased. So that like that website could throw a red flag, like your data set wouldn't be like complete in a whole. So on the other hand, when we explored retailers like ModCloth, we found that most of the like the essential data signals were present, and the other data signals could basically help accentuate the problem solving. So that's how we ended up creating the data set from ModCloth. And now you might have a question in mind, like what if we don't get all the signals from one particular web source? So it is very well okay, and it is very well possible that it happens. So in that terms, you think about the sarcasm data set, right? You cannot have a website or web source where it would have like sarcastic and non-sarcastic both news headlines, right? So in that case, we got sarcastic from one, non-sarcastic from the other, and we combine them. So it is completely okay if you combine data signals from multiple sources to create a wholesome data set. And another consideration then comes when you are doing like a guided search for creating a data set would be how much data is enough data. Um, and like how much data do you actually go back to for does the source contain enough historical data to construct a sufficiently large data set. So the data volume requirement is basically tied to the kind of the problem that you're solving. And in this case, when I say the kind of the problem, it could be the kind of machine learning problem. So be it classification or be it regression. So for people who actually know classification and regression, so let's say we have regression. So the outcome could be anywhere between minus infinity and infinity, depending on the target variable values that we have. So we can come up with intervals based on the target variable range and reckon that if most intervals of that target variable, they have at least a few data points, then we're good to go. For classification problem, where we have like a bunch of classes that we can put our data points into, we have to see that the number of data points to the ratio of the number of data points to the number of classes should be large enough. So let's say you have 20,000 data points, right? So they would be enough if we just had two classes and each could have say 7,000 and a 13,000 ratio. But if you had 10,000 different classes, in that case, at max, each class can only have two data points, which is not good for a machine learning model to learn upon or to generalize upon. So this step ends up becoming very open-ended depending on the kind of problem, the machine learning problem you're solving, and the kind of historical data you can go back to, and also personal preference. So, but that is one thing that you should keep in mind when you're doing a guided search. So these three things, we have to formal problem definition, essential data signal determination, and data volume requirement are the three main things that you should focus on while you're doing a guided search or for data set curation. The next comes unguided search, and this is for mostly like creative souls or just like planning to fashion an exciting and a distinctive worthwhile set, and to mostly like they don't have a particular problem in mind, they just want to have like some exciting uh, use cases or just build like a data set which could be used for a variety of reasons. So we can refer to the news category data set to further explain the challenges because we created that data set without having a specific problem in mind. But if you think a basic problem that could be like tagging the news articles with the data sets is a basic problem that one can come up with. However, you could use the same data set for multiple uses. We'll talk about what are the multiple uses. So the biggest challenge for unguided search of dataset is it involves a lot of uncertainty. Since we're not sure what kind of data signals we require because we do not know what the kind of problem we are solving, there's no proper structure of the consequence search operation. Although not knowing the problem is in itself a big problem, the following dimensions, they help you to structure the search basically. So one of the signs of a competent data set is that its signals can address some contemporary practical problems. So for example, when we talked about news category data set, not only you can help use it to train models to tag the data set, you could also use it to identify any prose's writing style. So does it have a political tone to it? Does it have a humorous tone to it? Is it a criminal report or is it based on the latest fashion trends and so on? So it can also help like track news articles or understanding the different writing styles or different news types or headline generation and so on. So this is like these are the different uses for the data set that we created, which was created without any specific problem in mind. And also another interesting thing when we look for a data set curation is the metadata association. So according to the research paper titled Patterns for Learning with Side Information, they talk about how generalization of the learned function to unseen data can be improved by incorporating side information into learning. So side information is data that is neither the input nor the input, but it has information about it. So basically, data about the data or information about the information itself is known as metadata or side data. And once you know that a signal is like has metadata, it helps. For example, it could be the dollar amount for it or the currency code for a particular item price. And once you know that which data signal is considered worth estimating, you should also ensure that the web source provides enough site information for the prediction task. And if it's not, you could either chuck that, or as we talked in the previous example, you could combine multiple sources. For example, predicting a product's price that we talked about, it is not only essential to know the number, but it's also good to have metadata about the brand of the product or the fabric of the product. So basically, data about the product itself, so data about the data. So including the sufficient site information helps. And the rest about data volume requirement, it's similar to what guided search approach. It's an open-ended thing. It depends on problem you're solving, and it also depends on the data availability that we have and personal preference. And then comes data uniqueness check. In that, you have to basically go through all the data sets that we have, because you don't want to spend your time, money, energy, effort on something that is already there. You need to have something unique out there. There's no pressure, but it's always a good thing that you come up with novelty, as I talked about previously, if you're working with a research group or something. So the bottom line is, when we talk about machine learning process, this is usually what people talk about, like defining a formal problem statement, appropriate metrics, model learning algorithm, and then deployment. But usually people focus on this aspect of a machine learning workflow, that is defining appropriate metrics to measure the success of the intelligent solution. People are like more focused on the success, and then choosing the appropriate model and learning algorithm to address the problem, like how well your model is performing, what's the accuracy rate, how are the metrics performing. But it's also important to focus on the previous steps, which is how do you source the data and fabricate your own data set? How do you process the data set and perform feature engineering? So it is very important because you lay a very strong foundation of your model. Sometimes your model might not be that fancy or that complicated, but the data that you have is of high quality, and it would eventually beat sophisticated algorithms, like to an extent, if they're trained with poor quality data or poor quantity of data. So in case you want to learn more about how to build your data set, as we talked about, like those 3 data sets, we'll actually, the book actually talks about how to build those data sets with Python code snippets and stuff using websites like Modplot, The Onion, and HuffPost. You can always go to Amazon.com and get this book. It's available both in ebook and paperback. And you would learn about the significance of data and how to identify relevant data signals, as I talked about today as well. So I covered like the first half kind of the problem, how to identify data signals based on the kind of approach you're going for data set curation. And then it will also talk about data processing, pre-processing, and feature engineering. The good thing is it's using Python and open source tools like Beautiful Soup. It will also introduce you to machine learning algorithms and paradigms like supervised learning, clustering, unsupervised clustering, association, and all from a data perspective, not from like an algorithmic perspective on what kind of data would work, is well suited for that particular paradigm. And it's also endorsed by ML experts. So if you want to read forewords by Julian Macaulay, who's an associate professor at UC San Diego, and my co-author worked with him, Lawrence Morney, who's a AI advocate at Google, and Mengting Huang, who is a senior applied scientist at Microsoft, feel free to purchase that book. And with that, I'm open to questions. Thank you so much for joining. If you have any questions about dataset curation, machine learning at work, or data science, I'm open to chat. Thank you so much.
Thank you, Jigyasa. We really appreciate that. So I think we're going to open it up to Q&A. Let's see. We'll take questions from attendees. There you go. Thank you. I'm going to enable my video here. Okay, very cool. So we'll take questions over in the chat stream. So far, I just see a lot of thank yous and good information. So that's always good. That's always some positive feedback there. But why don't we if you want to maybe check out Q&A, click on Q&A. Yeah, and if you want to take those there, that would be great.
I see the first question by Shambi Brume. Sorry if I'm pronouncing your name incorrectly. So they say it seems like Twitter and even Instagram is operating more like a search engine and searching all words in a tweet to find what's trending. Are hashtags going to become less important for social reach? Of course. So to answer that, definitely to search trends, not many people use hashtags. They end up using like they would extract the keywords from the latest tweets to find out trends. But I don't think hashtags are going to become less important, because when you think from a user perspective, you don't actually search for a word. Sometimes you see a tweet and just click on the hashtag or the trending hashtag, and then you see all the tweets. So from a user perspective, it's less of a hassle to click on a hashtag rather than to type the entire word and search for it. So I don't think hashtags are going to become less for social reach, but definitely there are other things that are catching up with how to find trends, recent trends. Hope that answers your question. Cool. Um, and Nancy Siphon, she's here, sorry, they say, what is the best way to start in the area of data scientist or data science? Yeah. So the best way to start would be I would say to take up a course online. There's so many, not even a course, just like watch lots of videos if you want to get started, read lots of books. And to get practical knowledge, I would say pick up a project or two. Open source projects are the best to learn, because it's not only you are working on them, there are so many other people across the world that are working. So you get to know the working temperaments of different people and how the project goes. Plus you have a lot of support going on. So work on different projects, build up a good resume if you want to work at a company or apply for a job. And that should be pretty much it. These days, people, they are not like very much focused on formal education, but more on your zeal and the kind of work that you worked on. So I hope that helps. Regarding the tools, you could work with, like, pick up a language like Python, and it's better to go depth-wise than to have like breadth-wise. Always good to have like a bunch of knowledge, but if you want to like be a master of none, like then jack of all trades kind of a thing. And Phil Smith said, I'd love to hear about where detecting social bias and racism should fall within the AI hierarchy of needs. Actually, that's a really nice question, Phil. I didn't really like ponder upon it a lot, but in my opinion, I think it should be at the very bottom, because it's the basic necessity one needs to do before we go upon like processing the data and so on. So while you're collecting the data itself, you should be very cautious about picking things which would actually introduce social bias. So maybe while you're doing feature engineering or engineering your features, preprocessing the data, you should always focus on anonymization and reducing that kind of bias at all. So I would say the first or the maybe second, between the second and the third level, it should come. Hope that answers your question. Cool. Bobby Compton says, for ML investigations, what % of time are you exploring supervised versus unsupervised learning techniques? I didn't quite get your question, Bobby, but considering it says like at work, if I have a problem and I need to think about supervised and unsupervised, I think usually it comes like what kind of a problem it is. And sometimes these things you learn with iteration. Sometimes you're working on something and they don't work, and then you go back. So I would say it's an iterative process, and you can't basically define a time. But if you think about general machine learning at work or in general, I would say supervised learning is more beginner friendly and more utilized than unsupervised learning currently. Yeah, I hope that answers. Like, you can always ask like a follow-up. Nancy says, thank you. Rich says, how do you avoid imposing user bias from the people sculpting the data? That's actually a very nice question. So it's always necessary that you're not the only person. If you put it out, you know, if you let's say you built a data set and you put it out for the world to use. Before that, it would be good if you put it out to research groups and they would give critical feedback. And if you work in a group, it's all like, so a one person user bias doesn't creep in. But that's a very important point that should have also been mentioned about how do you overcome user bias is by group efforts, by avoiding certain things that are in the rule book, let's say basic gender, or that we also talk about in the book, how we can reduce the anonymize the address, anonymize the gender, and like so and so. So basically, you have to avoid like working in a group, and before you put it out for the world to use in proper cases, it's good for research groups and all to give in their feedback. Justin says, do you have any tips to avoid turning an unguided search into result phishing? Not sure if I understand your question, Justin, but do you mean by turning an unguided search into result phishing would be where you're just finding different like you? I'm actually not sure. Could you like rephrase your question and I'll get back to it? That would be great. Moving on. Megan says, do you have any thoughts on the challenges for building data sets that include more regulated data like health data or finance data? So the challenges would be pretty much the same, I would say, except for finance data. Okay, actually, Mark said that. Okay, cool. I got lost by two windows. So the challenges for health data and finance data, basically, it would be, since you all know, like finance data changes so quickly. So how long do you go back into the history? And same goes with health, because symptoms change over the years. And even if you see with COVID, right? The strain gets mutated and the symptoms are changing throughout the world. Let's say in some parts of the world, it's just more related to throat issues, or like having cough and a sore throat, a lack of taste and smell. Whereas in some parts of the world, it's about your stomach going bad and so on. So I guess there are different symptoms, and you should like, these are the kind of challenges that you have to take care about. The part of like geography comes into place with finance, how much historical data that you have to go back into. So I guess it totally comes upon the use case. And when you like just jump into the process of building a data set, that's when the challenges come up. So far we haven't built any health data set, but that's a good problem to work with. I hope that answers your question, Megan. Ayur Krishnan says, as data/metadata collection increases, so does the noise in the data. Are we solving a problem, that sculpting data that we created in the first place? That's actually a very good question. So you said it does increase the noise, but again, you said in the data set, it's very necessary that we just keep the essential data signals, and then the metadata associated with those essential data signals that could help you reduce the noise. And definitely applied data set curation, or how to build a data set and feature engineering, are in itself a part of applied machine learning. So it's basically you create a problem and then you solve it. Yeah, that's just an iterative process that goes on. Hope that answers your question, Ayar. We can always chat more about it. Daniela says, thank you, Jigyasa, for a great presentation. You touched upon choice of language, open source projects to get up to speed with AI/ML. Can you talk to databases, SQL versus NoSQL? Can you share the databases you interact with at Twitter? So at Twitter, we have our own in-house database that we talk to. And I guess currently we use Google Cloud Platform BigQuery. So it's a more structured query language, SQL. So I guess SQL is good to start with. I was at Facebook previously, and from my experience, like the kind of project that I worked on also use SQL. So in my experience, I haven't gotten to use like NoSQL at work as of now. So I would say if you know one thing with perfection, and with like the other thing comes to you automatically. So I would say, as I said, go into depth, choose a project, choose a language, and choose a kind of query language that you go. Hope that helps, and thank you for the compliment. David says, for initial data exploration / quality patterns, feature importance associations, etc., what open source tool stacks do you prefer? The options change so fast. I'm curious what you prefer of the current best options. Curious for both small data enough to work with on a single node, and too big for analysis on a single machine. Thank you. Look forward for reading the book. Oh, that's great. David, I hope you enjoy reading the book. And to answer your question, for initial data exploration, I've always used basic pandas. That's what I use to find patterns and to explore the data feature importance. Even for feature importance, I've used sklearn, the feature importance tool, train a random forest, and then see what features line up. And then there are also like a variable feature importance neural networks that you could train on. There are different ways you could do. So I think things definitely change so far, but if you have your basics correct, let's say for feature importance of associations, you could just have your theoretical knowledge correct. Let's say for feature importance, as I was saying, random forests, we all know that can give feature rankings, right? So you can actually use any XGBoost or sklearn to apply that theoretical knowledge into practical. So things do keep changing, but if you have, that basic knowledge correct, and anything in Python would basically help. So sklearn would be a good choice to start with, or pandas would be a good choice to find patterns and feature importance for like small data sets. Hope that answers your question. Joanne says, I just got in a few minutes, where is she getting the questions from? So yeah, there's a Q&A feature. Nancy says, do you see a difference from data scientist versus data analyst? Currently at Twitter, I'm not really sure, because I do know people, there are data scientists, but not sure about data analysts. Maybe, yeah, I think that would be a question better suited for people who are who are working as a data analyst or a data scientist. So not sure, but I like, in my opinion, most of these are overlapping. So it just depends on the group that you're working with, the like the company that you're working with, and the title they give you. But generically, most of like machine learning engineering, data science, data analysis, they mostly come like over, like lots of job duties like overlap. Hope that answers your question. Coming back to this, okay. What are the most useful tools you've used? So if you want to talk about data set collection, the most useful tools, this is Mark Hutchinson, by the way. For data set collection, I would say in Python, Beautiful Soup, Selenium, and then using Chrome driver with it were the most useful tools in collecting the data sets. Like we've collected 3 to 4 data sets. With it. And if you talk about generic like machine learning, I would say to start with sklearn or scikit-learn is a great tool to get started with. Jupyter Notebooks is one of my favorites, because you can have basically everything in one. And then TensorFlow for work. That's pretty much it for the most useful tools. Hope that answers your question. Great question. Thank you, Mauricio. Thank you, Srinivas. Thank you, Colin, Rachel, Arnav. It did answer. Okay. Then Megan, I guess that was the same question about health data and finance data. Mark Hutchinson, what is a good ratio of data engineers, data scientists on an analytics team? I guess it depends on what kind of a product you're building. If it's more like, say, data oriented, or more like artificially intelligent solution, it's always good to have, I don't know, maybe 4 to 3 or something. But it totally depends on the scale of your company, the scale of your organization, and so on. Phil says, thank you. Thank you, Phil, for coming. Akshay says, never thought about this way. Thank you. Oh, great that I introduced you to a nice way of thinking. But yeah, it's always good to know where your data comes from. And many people usually think like, oh, machine learning, let's pick up a data set from the web. They seldom think about, oh, I should build a data set myself. And that is something that I would encourage, because that will not only help solve your problem, but it might help build the community. It might help you to contribute to the community. So in the book, as I talked about, there's also a link to a special GitHub repository or a gist, where you can just simply copy paste the code, like the code snippets, and like tweak them to build your own data set. So yeah, you get +1 with that book. Todd says, hi, Joanne. Okay. David says, awesome. Thank you to the answer. Thank you, David. Thank you. Jen says, I see that this is being recorded. Oh, cool.